Okay, we're going to get a little practice with factoring, a little review. Some of this should seem familiar to you as we've talked about this before, but the first issue that we have here with factoring is just trying to get out the GCF, the greatest common factor. So, what's the largest thing that goes into both terms? Now, as you look at number one here, you got to look 12x cubed plus 8. Well, there's not an x in both those, so nothing with the variables. So, let's think what's the biggest number that goes into 12 and 8? Well, I think if we do this correctly, I think we can see that a 4 would go in out of those. So it's kind of like undistributing here. Oopsie. So we take a 4 out, and what we'd be left with is 3x cubed plus 2. So if you distribute that 4 back in there, you should get what we started with. So it's kind of like working backwards of the distribution property. That's what factoring kind of is. So think of it as undistributing in many ways. All right, so let's try number 2. Now we have 3 terms here. So now I have to figure out something that goes into all 3. So let's see, all 3 terms do not have an x, so I can't factor out any x's. So I'm going to look at between 15, 10, and 20. Looks to me as if a 5 would come out of those, out of all 3 of those. So what we'd be left with there is a 3x minus 2x squared, and then we'd go plus 4. So just divide those out of there is what we are doing there. All right, well, let's go on to number 3. Now, number 3, you can see, oh, okay, so it looks like a 4, 5, and an 8. Well, 5 is a prime number, so there's not a number that goes into, it's got to come out of all 3. You know, the 4 and the 8, you'd be thinking 4, but 5, there's nothing there. But as I look at the x's, we have an x squared, an x to the third, and an x. It looks to me as if we could take an x out of all those. And so now what that does is reduces the exponent down by 1, so the 4x squared becomes a 4x. The 5x cubed becomes a 5x squared, and the 8x, sorry about that, the 8x just becomes an 8 is what happens there. All right, let's take a look at number 4. Is there anything that goes into 12, 9, and 7? Nope, so I can't take anything out of the numbers. But this time I have an x squared, x cubed, x to the fourth. So it's always the smallest power that we can take out. So we can do an x squared out of all those. So I'd have a 12. This would become a 9x, and this would then become a 7 minus 7x to the second is what we'd end up there. All right, number 5, let's see. Oh, this time, 6 and 4. Yeah, we can. Those are both even numbers. We can take a 2 out of there, and then we can also take an x. So what would we be left with? 3x plus 2. Yeah, okay. What about number 6 here? 18x to the third, 6x squared. I think we can take a 6 out of both of those and an x squared. And what we have left is a 3x. Well, let's see, I took a 6 and the x squared, so what's left is 1. Yeah, if everything goes out of there, that's multiplied by 1. Yeah, kind of tricky. All right, now number 7 and 8 get a little crazy kooky now. We have 3 terms, and 10, 5, and 20 looks like I could take a 5 out of those, and it looks like I could also take an x. So now we'd be left with a 2. Looks like if I take an x, that'd be an x squared, and this would be, I think, a 4x. How about that? There we are. Wow. Crazy kooky. All right, number 8, 4x for the fourth, 12x third, x squared. So it looks like I can take a 4 and an x squared out. And what I'm left with then would just be an x squared plus 3x. And then that would just be plus a 2.